So our opening question today is this. Evaluate this integral from 1 to 4, 1 over x minus 2 dx, and interpret the integral as an area under a curve. So a nice, basic, easy question. I want you to pause the video, do that, and see what you come up with. All right, so hopefully you're back now, and hopefully what you did was you would have said that the integral from 1 to 4 of 1 over x minus 2 dx is equal to, well, let's see, the antiderivative is ln absolute value x minus 2, and that's from 1 to 4. So now I'm going to plug in the 4 and get ln of 2, minus plug in the 1, I get, it's 1 minus 2, so that's negative 1, but then I have absolute value, so that's positive 1. So I have ln of 1, which is 0, so I just get ln 2, right? So ln 2, easy as pie, right? So what if you check that with a calculator? All right, so I did that already. Here's me putting that same integral that we had into the calculator. This is error. What? What's wrong with my calculator? Let's try a different calculator. This calculator. Here's the same integral. A little glare there. Let's try to move that glare off. This one says undefined. I'm trying to highlight that and it doesn't want to let me. There we go. Undefined. Weird. Why undefined? Why error? Okay, what's going on? Let's try to interpret this as an area under a curve. What does this graph look like? Yeah, so you could do this in a graphing calculator, but it's actually very easy to do by hand. You should be used to doing this by hand. We have a vertical asymptote at 2. So here's 2, x equals 2. Really, that already tells us what the problem is. There are no x-intercepts, because if I set the numerator equal to 0, I get no solutions. The y-intercept is put 0 for the 2. The y-intercept is negative 1/2. So here's our y-intercept at negative 1/2. And I have a horizontal asymptote at y equals 0 because the degree of the denominator is 1, the degree of the numerator is 0. So I have a horizontal asymptote at y equals 0. That's all we got. That's all we need. It's an odd asymptote because the degree of the factor is 1, which is odd. So that means that the graph goes like this and like this. All right, then where's the interval on that graph that we're trying to do 1 to 4. So here's 1 and here's 4. And so clearly what the problem is we're trying to find an area that contains a vertical asymptote and therefore goes up forever. All right, so it's not surprising that it's some kind of infinite area. This calculator was specifically said that area was undefined because there's a negative infinite area and a positive infinite area, and negative and positive infinity don't really just cancel each other out because those infinities can have sort of different relative values, and there's a lot you can say about that, but today is not the day for it. But so suppose, for example, we just wanted to look at the integral from, let's just take the positive part of it, the integral from 2 to 4 of 1 over x minus 2 dx. And let's just use the calculator, this calculator, which is pretty sophisticated to tell us what that is. So what I can do is just copy this. So we just do Control C, just like in Word, and then Control V. All right, and then I'm going to replace the 4. Oh, no, I'm going to replace the 1 with 2. All right, so delete that. I'm going to put 2. Okay, so I'm going to see what that integral is. So this time, if you can see what it says there, I think I get any part of that. Yeah, so that's infinity is what that says. It's a little not entirely obvious from this angle, but that says infinity. So that integral is infinity. So what's interesting is first of all, this integral that we did here, that it said it was ln 2, that is wrong. We cannot do that. Because an infinite area is contained, this integral somehow is undefined. Undefined because there's both a positive infinity part and a negative infinity part. Whereas when I do this integral, where I take only the positive infinite part, I get infinity for a value, which sort of makes more sense. Okay, and the reason that this happened is because I tried to evaluate an area that has an infinite boundary. So the next question, though, is Do areas with infinite boundaries always have infinite areas? And that would not be an interesting question if the answer was no. So in fact, it would not be an interesting question if the answer was yes. In fact, the answer is no. And to see that, we're going to investigate our next integral, which is going to be the integral from 0 to 4 of x to the negative 1/2 dx. So the thing I want to point out before we move on to doing that is this integral appears entirely innocuous. There's nothing about looking at this integral that obviously shows that if I do the things that I normally would do to find the integral, I will get the wrong answer. I got an entirely wrong answer. I thought it was ln of 2, but it's actually undefined, all right? But there's nothing about this integral or any of the work that we did. I didn't, get anything that was undefined. I didn't have to divide by 0. Nothing. There was nothing about the work that indicated that there was a problem with the integral. The only way that I know that this integral has something weird about it, in fact, is improper, is by understanding the integral as an area and understanding that that area contains a vertical asymptote. Therefore, this integral requires special treatment that we can only perceive by looking at the graph. I mean, we could also think about by saying, where is this function undefined? Is at x equals 2? And x equals 2 is in fact between 1 and 4. So that's analytically how we know that this integral is improper. All right, but to really understand why that is problematic and what it's doing, we need to look at the graph. Okay, so the next thing we're going to do is look at this integral. And the reason I sort of went back to that is it isn't entirely obvious looking at this integral either that it's improper. This does say negative 1/2. I'm going to try and write that a little more clearly because I think it's not showing up very clearly. X to the negative 1/2 dx. So it's not entirely obvious that there's something improper about that integral, but there is. It's a little more obvious in this one than with the other one because of the 0 and the negative exponent puts the x in the denominator. All right, so we'll talk about this integral next.